Welcome to Crashcast Java, where we dive deep into the world of Java programming. I'm Victor, and today we're joined by our resident Java expert Sheila. We'll be discussing an exciting topic, the performance comparison of ForkJoin versus traditional multi-threading. Sheila, can you give our listeners a quick overview of what we're talking about?
Absolutely, Victor. We're essentially comparing two approaches to handling concurrent programming in Java. On one side, we have traditional multithreading, which has been around since the early days of Java. On the other, we have the ForkJoin framework, introduced in Java 7. Both aim to improve performance by dividing work among multiple threads, but they go about it in different ways.
That's a great starting point. Before we dive deeper, could you explain what multithreading is for our listeners who might be new to the concept?
Of course. Imagine you're cooking a complex meal. Instead of doing everything yourself, you have multiple chefs working on different parts of the meal simultaneously. That's essentially what multithreading does in programming. It allows a program to perform multiple tasks concurrently, potentially speeding up execution, especially on multi-core processors.
I love that analogy. So how does the ForkJoin framework differ from traditional multithreading?
Well, the ForkJoin framework takes this idea a step further. Instead of assigning fixed tasks to each thread, it uses a divide-and-conquer approach. It's like having a team of chefs who can dynamically split up the work and help each other out when they finish their tasks early.
That sounds efficient. Can you elaborate on how this division of work happens?
Certainly. The ForkJoin framework uses what's called a work-stealing algorithm. Imagine each chef or thread has their own to-do list. If a chef finishes all their tasks instead of standing idle, they can steal work from other chefs who still have items on their list. This keeps all the threads busy and balances the workload automatically.
Fascinating. So when would developers choose ForkJoin over traditional multithreading?
Great question. ForkJoin really shines when dealing with recursive divide-and-conquer problems. For example, processing large datasets like sorting a huge array or traversing a complex tree structure. In these cases, the problem can be broken down into smaller, similar subproblems, which is perfect for ForkJoin.
I see. Are there any performance benefits to using ForkJoin in these scenarios?
Absolutely. In many cases, ForkJoin can offer significant performance improvements, especially for problems that can be easily divided. The work-stealing algorithm ensures efficient use of available CPU cores, reducing idle time. However, it's important to note that for simple, non-recursive tasks, traditional multithreading might still be more appropriate.
That's a crucial point. Are there any other considerations or potential pitfalls developers should be aware of when choosing between these approaches?
Yes, there are a few things to keep in mind. First, the ForkJoin framework has some overhead, so for small tasks, it might actually be slower than traditional approaches. It's most effective for computationally intensive tasks that can be broken down into smaller parts. Also, developers need to be careful about how they split the work. If tasks are divided too finely, the overhead of creating and managing all those small tasks can outweigh the benefits. On the flip side, if tasks are too large, you might not fully utilize all available threads.
Those are great points, Sheila. It sounds like there's a bit of an art to using ForkJoin effectively. How about we recap the key points we've covered so far?
Certainly. We've discussed that traditional multi-threading assigns fixed tasks to threads, while ForkJoin uses a divide-and-conquer approach with work stealing. ForkJoin is particularly effective for recursive problems and large datasets. It can offer performance benefits through better CPU utilization, but it's not always the best choice for every scenario. Developers need to consider task size and complexity when deciding between ForkJoin and traditional multi-threading.
Excellent summary. Now, for our more advanced listeners, could you mention a few advanced topics related to this subject that they might want to explore further?
Absolutely. 3 advanced topics worth exploring are 1. The internals of the ForkJoin pool and how it manages worker threads. 2. Implementing custom recursive task and recursive action classes for complex problems. 3. Combining ForkJoin with Java 8 streams for even more powerful parallel processing.
Those sound like fascinating areas for deeper study. Well, that brings us to the end of today's episode. Thank you, Sheila, for sharing your expertise with us, and thank you, listeners, for tuning in to Crashcast Java. If you enjoyed this episode, Don't forget to subscribe for more deep dives into the world of Java programming. Until next time, happy coding.